Okay, we're gonna now move on to example 3. So I have 2 tangent squared x equals sine x over cosecant minus 1 plus sine x over cosecant x plus 1. Um, Now, remember, we're not allowed to add, subtract, multiply, or divide both sides of the equation by anything. We need to pick a side, work on it, try to simplify it. So the right side seems the obvious choice to try to work on. It does look intimidating, but there's strategies we can use here. So what we're looking at here is a fraction plus another fraction with unlike denominators. I think at this point, converting the denominators to sine would be a bad idea, because then you would have sine x in the numerator, 1 over sine x minus 1 in the denominator. So now you have a fraction within a fraction. That's going to become a little confusing for some of you. So take a look at the denominators and look for the least common denominator of these two fractions, right? That's the least common multiple of the two denominators here, cosecant x minus 1, cosecant x plus 1. So in this case, the least common multiple is going to be cosecant x minus 1 times cosecant x plus 1, which means on the left fraction here, I need to multiply the numerator and denominator by cosecant x plus 1. And on the right, I need to multiply the numerator and denominator by cosecant x minus 1. So let's set that up now. It does start to get big and intimidating, right? This is mostly algebra, so your fraction skills are going to be critical here. So on the left fraction, I'm multiplying by cosecant x plus 1 to the numerator and denominator, and we're going to distribute in the numerator, right? It's a good idea to keep your denominator factored at first until you add the two fractions together, okay? And on the right side, I'm going to multiply by the denominator of the left fraction. That's the other part of that least common multiple we were working with. So that's cosecant x minus 1 time, in the numerator times cosecant x minus 1 in the denominator. Again, distribute in the numerator. Keep your denominators factored at first until you combine the two big numerators. So we're going to distribute sine x to both terms here, and then sine x to both terms here, and see what happens. So in the numerator, sine x times cosecant x, those are reciprocals of each other. So this is going to simplify to 1. And then sine x times 1 is sine x. Now in the numerator, I have 1 plus sine x. Look, I kept my denominators factored. On the right, again, distribute sine x to both terms. Same idea, sine x times cosecant x. Those are reciprocals, so it simplifies to 1. And then sine x times negative 1 is negative sine x. Now that I have common denominators for both of these fractions here, I'm going to add them. Now be careful. If this was a subtraction, you would need to distribute the subtraction to both terms, right? That's a critical mistake if we forget to do that. However, in this case, we're adding. So we're just going to add the numerators together. So I have, like terms. So 1 plus 1 is 2. And then sine x plus negative sine x is 0. So now I'm going to be left with a 2 in the numerator, and then my denominator down here, right? So before we go any further, I'm going to peek back up to look at what is it we're trying to verify right here, 2 tangent squared x. So in my numerator, when I combine these, that 1 plus 1, that's my 2. And then I have sine x plus negative sine x, which becomes 0. So I'm looking now to see how can I get a tangent squared x in my numerator to verify this. So let's keep working. So there's my 2. And then now is a good time, because can't really simplify any further, to possibly multiply the factors in my denominator. Again, this is a distributive property step where I'm going to multiply both terms in the left group to both terms in the right group, and hope maybe this gives us a Pythagorean identity, because I'm multiplying cosecant x to cosecant x. That'll give me a cosecant squared x. I will also have a negative 1 times a positive 1. So that'll give me the foundation of a Pythagorean identity. I'll have a trig function squared minus 1. So that might be a Pythagorean identity. So let's look at what happens when we do that. So this is the work here for the distribution in the denominator, cosecant squared x plus cosecant x minus cosecant x minus 1. These two middle terms negate each other to 0, and I'll be left with cosecant squared x minus 1. And now I'm going to look for a Pythagorean identity, right? Cosecant squared x minus 1 is, cosecant squared x is really 1 over sine. So I'm going to take the original Pythagorean identity and divide it all three terms by sine and see what happens. So cosine squared over sine squared gives me cotangent squared. Sine squared over sine squared gives me 1. 1 over sine squared gives me cosecant squared. I'm trying to make cosecant squared minus 1, so I'm going to subtract the 1 here in the middle identity from both sides, and that'll give me cosecant squared x minus 1, which is exactly what my denominator here is. So I can now translate to cotangent squared x. So now I have 2 over cotangent squared x, and I'm trying to produce 2 tangent squared x. So remember, cotangent squared x is the reciprocal identity of tangent squared x. So you could do this one of two ways. You can deconstruct this fraction to 2 times 1 over cotangent squared x right here. Okay. And then you can translate 1 over cotangent squared x into tangent squared x. Some of you have a strong knowledge of fractions and know that you could just take this 2 over cotangent squared x and rewrite it as 2 tangent squared x. This piece is nice because it verifies your understanding of that concept. So I'm going to replace 1 over cotangent squared x with tangent squared x, and now I've verified my identity. 2 tangent squared x is equal to 2 tangent squared x.